Download this code from codegive.com, link in the description below. Building resilient applications in .NET requires a combination of design principles, architectural patterns, and the right tools. One way to achieve resilience is by using a development proxy that can simulate failures and network issues during testing. This tutorial will guide you through building a resilient .NET application and how to use a development proxy to test it effectively. 1. Understanding resilience. Resilience in software refers to the ability of an application to handle failures and continue to operate. This may involve graceful degradation, the app continues to function with limited capabilities. Retry logic, automatically retrying failed requests. Circuit breakers, preventing calls to a failing service until it recovers. Timeouts, ensuring that calls to dependent services do not hang indefinitely. 2. Setting up your .NET project. First, create a new .NET application. You can use ASP.NET Core for web applications. Bash. .NET New Web API and Resilient App. CD Resilient App. 3. Adding required packages. To implement resilience patterns, you can use libraries like Poly. Install Poly via NuGet. Bash. .NET Add Package Poly. .NET Add Package Microsoft.extensions.http.poly. 4. Implementing resilience patterns. Here's how to implement a simple HTTP client with retry and circuit breaker policies using Poly. 4.1 Configuring services. Open startup.cs or program.cs, depending on your .NET version, and configure HTTP client with Poly. Sharp. Using Microsoft.extensions.dependency injection. Using Poly. Using poly.extensions.http. Public class program. Public static void main, string args. var builder equals web application.create builder, args. / configure services. Builder.services.add HTTP client weather service. Add policy handler, get retry policy. Add policy handler, get circuit breaker policy. Builder.services.add controllers. var app equals builder.build. App map controllers. App run. Private static async policy HTTP response message get retry policy. Return HTTP policy extensions. Handle transient HTTP error. Wait and retry async. 3. Retry attempt equals time span. From seconds, math.pow. 2. Retry attempt, / exponential backoff. Private static async policy HTTP response message get circuit breaker policy. Return HTTP policy extensions. Handle transient HTTP error. Circuit breaker async. 2. Time span. From seconds, 30, / break on 2 consecutive failures for 30 seconds. 4.2 Creating a service. Create a service that will use the configured HTTP client. Sharp. Public class weather service. Private read-only HTTP client _HTTP client. Public weather service, HTTP client _HTTP client equals HTTP client. Public async task string get weather async, string city. var response equals await _HTTP client get async, $https://api.weatherapy.com/v1/current.json, key equals your _API _key and q equals city. Response.ensure success status code. Return await response.content.read as string async. 5 Using a development proxy. To test your application under various failure conditions, you can use a development proxy like wiremock.net or mock server. These tools allow you to simulate HTTP responses, including failures. 5.1 Installing wiremock.net. Install wiremock.net via NuGet. Bash. .NET add package wiremock.net. Standalone. 5.2 Starting wiremock. You can run wiremock as a standalone server. Create a new console application and configure wiremock. Sharp. Using wiremock.server. Public class program. Public static void main, string args. var server equals wiremock server.start, 5000, / start wiremock on port 5000. / set up a response with a failure. Server.given. Request.create, .with path, / weather, .using get. .respond with. Response.create, .with status code, 500. Console.read wiremock running at http / localhost 5000. Console.readline. Server.stop. 5.3 Testing your resilient app. Now, you can run both your main application and the wiremock server. Update your weather service to point to the wiremock server for testing. Sharp. Public class weather service. Private read-only HTTP client _HTTP client. Public weather service, HTTP client _HTTP client equals HTTP client. Public async task string get weather async, string city. var response equals await _HTTP client get async, $http / localhost 5000 / weather. Response.ensure success status code. Return await response.content.read as string async. 6 Running tests. Now, run your application. When you call the getWeatherAsync method, it should hit the wiremock server, which returns a 500 status code. The Poly policies will handle the failure according to the configured resilience patterns, retries and circuit breaker. 7 Conclusion. This tutorial demonstrated how to build a resilient .NET application using Poly for resilience patterns and wiremock as a development proxy to simulate failures. You can expand on this by adding more resilient features, logging, monitoring, and integration tests to ensure your application can handle various failure scenarios effectively. Additional resources. Poly documentation, https://github.com/app-vnext/poly. Wiremock.net documentation, http://wiremock.org. Microsoft documentation on resilience, https://docs.microsoft.com/n-a/microservices/microservice-architecture-resilience. With these practices in place, you can ensure that your applications are robust and reliable in production.